Good morning, everybody. Today we will continue our lesson Energy. We will go through part 2 of this lesson. In this session, we will determine the potential energy of a system. Potential energy. Potential energy is the energy stored in a system due to the interaction between its constituents. Potential energy depends on the positions of the constituents of the system. We will take in this lesson systems made up of at least two constituents. One of them is Earth. Look at the car going up the hill. When going up the hill and then going down, its potential energy changes. How? We will go through this in the next slides. Types of potential energy. The first type is gravitational potential energy, GPE. It is the energy stored in an object due its position above a certain energy level, a certain reference level. Usually we take Earth's surface as the reference level for GPE, but sometimes choosing the reference level is optional. If you change the reference level, you will change the value of gravitational potential energy. How? Because E equals mgh. M is the mass of the object, G is the gravitational field constant, and h in meters is the position of the object, the vertical position of the object above the reference level of GPE. So changing the reference level of GPE changes the value of the energy as well. This is an application about a uniform rod whose center of mass is G, basically present in the middle of AB because it is uniform. Its length is AB equals 0.6 meter and it makes an angle 30 with the horizontal. In part 1, you are asked to determine the gravitational potential energy of the system rod Earth by changing the reference levels of GPE. For example, in part A, you are given the reference level as the horizontal plane containing point A of the ground, or the ground as the reference level of GPE. Consequently, the position of G with respect to the ground is H equals AG sine 30, where AG equals AB over 2. So AG sine 30 equals 0.15 meter. Then you can calculate GPE by mgz or mgh. 2 times 10 times 0.15, GPE equals 3 joules. In part B, they have changed the energy reference level, and it is now the horizontal plane containing the center of mass G of the rod. So in this case, the position of G with respect to the horizontal level taken as the reference is H equals 0 because G is now contained in the reference level of GPE. So GPE equals 0 as well. Now in part C, the reference level is taken as the horizontal plane passing through B. So now G is at negative position with respect to the reference level. It is H equals minus GB sine 30 or minus 0.15 meter, and then GPE equals 2 times 10 times negative 0.15 equals negative 3 joules. In part B, in number 2, the rod is rotated counterclockwise until it becomes vertical. Now, deduce the variation in the gravitational potential energy of the system. Variation means the final minus the initial. So, delta GPE equals GPE final minus GPE initial. GPE final, it's mg times h, where h equals ag, because g is now in the vertical position. And GP1 equals mg with ag sine 30. So delta GPE equals 3 joules. Delta GPE does not depend on the choice of the reference level. So the value 3 joules will stay the same with the three parts, taking part A, part B, or part C, and changing the reference level. Delta GPE never changes. This is another example about a suitcase with mass 1 kilograms placed at the top 2-meter high cupboard. If the ground is taken as the reference level of GPE, you'll notice that the potential energy at the top is mgh, it is 19.6 joules. When the suitcase falls down, h decreases gradually. Consequently, the potential energy decreases as well, and it reaches a minimum value of GPE equals 0 when the suitcase reaches the ground, because now h equals 0. The second type of potential energy is elastic potential energy, EPE. It is the energy stored as a result of deformation of an elastic object. For example, when a spring is compressed or stretched by a length E or X, it stores in it EPE of the formula 1 over 2 Ke square, or 1 over 2 Kx square, where K is the spring constant measured in newtons per meter. E or X is the extension or compression of the spring, and E is the elastic potential energy in joules. Application 3. Consider figure 9, where there is a ball of mass 500 grams compresses the spring by a displacement of 10 centimeters. When the spring is released, it returns to its natural length and the ball is ejected with a speed of 1 meter per second. Neglect all friction. In part 1, you are asked to calculate the kinetic energy of the ball at the instant of ejection. This is a direct application of the formula of the kinetic energy, equals 1 over 2 mv square, where m equals 0.5 kilograms and v is 1 meter per second. So the kinetic energy of the ball at the instant of ejection is 0.25 joules. In part 2, you should deduce the maximum elastic potential energy that was stored in the spring. Of course, according to the principle of conservation of energy, which says that energy is neither created nor destroyed, it transforms from one form to another, we can conclude that the kinetic energy of the ejection of the ball was mainly the elastic potential energy stored in the compressed spring. So after releasing the spring, the work done by the restoring force, which is the force that tends to bring the spring back to its initial length, results in the transformation of the stored elastic potential energy into kinetic energy. So EPE equals kinetic energy equals 0.25 joules. Now, after calculating EPE, we can simply calculate the stiffness of the spring in part 3 with the formula 1 over 2 kx square, and in part 4 we are asked to reduce the magnitude of the restoring force when the spring is compressed by 10 centimeters and specify its direction. As we have just said, the restoring force in newtons is the force that tends to release the compressed spring into its initial length. So its direction is consequently to the right towards O, and its magnitude according to Hooke's law is T equals K absolute value of X equals 5 newtons. Kindly solve the following exercises. Please, before solving any exercise, always try to draw the figure for better imagination, for better or easier solving of the exercise. Okay? Have a nice day and thank you.